Now let us do some problem sets taken from the book. For problems 43 to 46, solve the exponential equation algebraically using logarithms. So our number 43 is five raised to 3x is equal to 786. So how do we solve this equation in terms of algebra? We could use the log formula. Am I correct? So we could solve this using the logarithmic property. So 3x log of 5 is equal to log of 786. Now there's a difference between the common logarithm and the natural logarithm. If we are dealing with numbers and we don't have any ln or the symbol that makes up for the natural logarithms, such as this one, if you don't see this form in an equation, then we're going to use, normally we use the log, the common logarithm, log, okay? And when we say common logarithm, these logarithms are on the base 10, but we don't really need to write the 10 because that's understandable. So in this case, we use the natural or the logarithmic, the common logarithm, okay? And to solve for x here, then what we're going to do next is to divide, of course. To divide our expression on the left by log of 5. So this gives me, I divide this by log 5 and the corresponding expression on the right also by log 5. And then in this case, I could cancel now my log 5. So giving me 3x is equal to log of 786 over log 5. So my x is equal to log 786 over 3 log 5. Notice that we just simply put down our 3 here on the denominator of the right side. And that's a shortcut. We could always divide this by 3 also to put a 3 here. So that's the shortcut thing. So anyway, this is the answer. Now getting your calculator, okay, you must be able to get or obtain a value which is equal to log 786 divided by 3 log 5, and that gives me, when rounded off to the nearest 10 thousandths, will give me 1.3808. So this is the answer, okay? Now to check the solution, whether it is accurate or not, just simply substitute this value to the x in here. Okay, so use your calculator to solve it. So what if my x is 1.3808? So let me try that. 5 raised to 3 times 1.3808 is equal to 785.983. So that means that I could easily round it off to 786, and we have a valid answer. Okay? So this is a valid answer. Okay, now we go to number 44. My number 44 is, but first let me have a boundary that separates the equations. Okay, so my number 44 is 8 raised to 0.2x is equal to 98.6. And again, this is similar to the number 43 in that we're going to use the common logarithm function or property. So 0.2x log 8 is equal to log of 98.6. And my x then would be, I'm going to divide this by 0.2. 0.2 log of 8. So the same is true here, 0.2 log of 8. And my x would be equal to log of what's wrong with the pen? Something's wrong with the pen. Okay, so this will be equal to log of 98.6 all over 0.2 log 8. And that will give me, okay, if you have your calculator with you, let's solve it together. So log 98.6 divided by 0.2 log of 8. And that gives me 11.0392, rounded off to the nearest 10 thousandths. Okay, so that is my answer for number 44. Okay, and if I want to confirm or to verify or to check whether I've got the right answer, I'm just going to substitute my x is equal to 11.0392 to the x here. Okay? Number 45. Okay, so I'm doing like a separator here. So for number 45, 45, 0.80 or 0.8 raised to 0.4x is equal to 2001 or 2001. Okay, now using the logarithm again, this is similar to number 43 and 44. That would give me 0.4x log 0.8 is equal to log of 2001. And that will give me my x is equal to, I'm getting the shortcut way now, okay? So log of 2001 all over 0.4 log of 0.8. Therefore, my x is equal to, okay, let's do this together. Log of 2001 divided by 0.4 log of 0.8 will give me negative 85.1626 or 27, rounded off to the nearest 10 thousandths. Okay? So if you want to correct this or if you want to check this, what you're going to do is just substitute your x here, and let's see if you get the same answer. And that's if the expression, if the value here equals the value here, then you've got the correct answer. So let us check. Okay, 0.8 raised to 0.4 times negative 85.1627. This is equal to 2001.001185. Therefore, we've got the right argument, or we've got the right value for x. Okay, how about the last number, number 46? Let's do it below. We still have a space here. Okay, so number 46, that's 6 raised to negative 5x is equal to something is wrong with the pen. Okay, is equal to 0.007. So I'm going to use the log property again. Negative 5x log 6 is equal to log of 0.007. And my x will be equal to log 0.007 over negative 5 log 6. And this will give me x is equal to, okay, let us do this together. We have log 0.007 log 0.007 divided by negative 5 log 6. So this will give me a value of x which is equal to 0.55539. And if you want to check this, if you want to verify if the answer is correct, then all you have to do is to just substitute this value of x to the x in number 46 here. Okay? So these are the answers for problems 43 to 46. Now let's do the earlier problems. Okay? And we will start from problem 21 up to 36. So these are short exercises just to test your knowledge and definition of the properties of logarithms. Because once you are master of the properties of logarithms, then any logarithmic equation, logarithmic, what do you call this, premise could be solved by your knowledge of these definitions and properties. So what we're going to do here in numbers 21 to 36, okay, but I only cut it up to 30, and the rest are in your book actually. So what we're going to do here is to fill in the spaces, the blanks, or the values which highlight the properties and definitions of the logarithms. So we start with number 21. Our number 21 states a premise with log 7 plus log 3 is equal to log of. Of course, this would be started with we could start it by dealing with the property. So this property actually denotes the property of the product, right? So this will be 7 times 3, and it's a common logarithm, right? Because it is raised, or the base is e, actually, or I'm sorry, the base is 10, okay? The base is 10. When you don't see any base for a given logarithm expression, then the base is 10. But we don't really need to write it, just to remind you. Okay, so this will be log 7 times 3. So that will give me log of 21. Okay. Number 22, log 5 plus log 8. This is similar to number 21. This will give me log of 5 times 8, which is equal to log of 40. Okay, how about number 3 or number 23? That's natural logarithm 48 minus natural logarithm 12. This is a property which denotes that of a quotient. So this will be ln of 48 divided by 12, or simplifying gives us the natural logarithm of 4. Okay? And whatever the value of that natural logarithm could be obtained using the calculator. Okay, similarly for number 24, this is again a quotient property, okay, for logarithms. So this would be ln of 4 over 20, giving us a value which is equal to ln of 1 over 5. Okay, how about number 25? For number 25, it's a mashup, or it's a mixture of both the quotient and the product, because we have separating operations, negative and positive. So this indeed gives us a mashup. So that means that first we have to take the quotient. So that will give me log of 8 over 5. Am I correct? And then we can see that this is plus 35. So that means that the 35 goes up. So 8 times 35 over 5, giving me, it does give me a log function which is log of, well, we can just simplify this one. So this becomes 8 times 7, so that would be 56. Okay, so log of 56. Number 26, log 2000 minus log 40 minus log 2 is equal to, okay, now we have two minuses. We have this minus here and minus here, meaning that this is actually two what do you call this? Two numbers in the denominator and one number in the numerator. So our 2000 would be on the numerator, and our 40 and 2, because they are both containing the minus sign, then we will have these two values at the denominator. And this will give me, okay, I could just actually perform some simplification. So this one could be divided here. So that's 1000 over 4, or 100, I'm sorry, 100 over 4. And 100 over 4 is just 25. So that gives me, that leaves me the final value, numerical value of 50, or 25, I'm sorry. Okay, 25. Right? So if you're not sure, let's see. So 2000 divided by 80. That gives me 25. So that's pretty much correct. Okay, number 27, 5 ln of 2. This is a property indicating the power rule. So this should be ln of 2 raised to the power 5. And in other words, this will give you ln of 32. Okay, what about number 28? Number 28 is similar. So this will give me ln of 3 raised to 4. And that actually gives me a value which is equal to ln of 81. Number 29. Log 125 is equal to blank log 5. Okay, this is also a power function, but it's kind of tricky. So this one should be, your log 125 could also be expressed into log 5 raised to 3. Am I correct? 5 times 5, 25. Now, to be sure, let us have the calculator. 5 times 5 times 5, that's equal to 125. Therefore, 5 raised to 3. And of course, since this is a power rule, just place this 3 here, transfer it behind the log. So that will give me 3 log 5, right? Okay, how about number 30? So number 30 log 64 is equal to blank log 2. So again, we have to express 64 in the base, or in an expression that gives 2 raised to a certain exponent. So that would be 2 raised to 6. Now let us check. If we have 6 2's, so 2 times 2 times 2 times 2 times 2 times 2, 2, 4, 6, that's equal to 64. Therefore, we are correct. And just place this 6 here behind the log, so that gives us 6 log 2. Therefore, the answer is 6. This is 3. This is 81, 32, and so on and so forth. Okay, so these are the answers for problems 21 to 30.